Okay, let's have a look of lab 5. There we have 3 parts. I guess we'll take like 20 or 30 minutes to finish them all. So at first, we may have a look of the knowledge we may need to know before we attend this. When we look at the specification of the document, you can see here. Can you see my screen? This one. You can find a very important keyword, which is MCS. What is MCS? The MCS is, we can have a look of this table to know what is MCS. So basically, we want to use MCS to help us to figure out what is the data rate, the transmission rate from sender to receiver. So how can we use this table to help us to calculate the speed of our Wi-Fi? Let's have a look of the left corner here. It's MCS index. So the MCS index is the modulation coding scheme index. And what is HT and VHT as well as HE? The HT is high throughput, and the VHT is very high throughput. HE is high efficiency. And why do we have these 3 kind of stuff? Because we know we have a lot of version for the AO 2.11 protocol. So for the HT is corresponding to the AO 2.11n, and the very high throughput is corresponding to the AO 2.11 AC, and the high efficiency is corresponding to the AO 2.11 AX. So usually we use this one, high throughput, since our Wi-Fi signal is in the protocol of AO 2.11n. But if you are using another like advanced Wi-Fi router, you may need to use another two. So it depends on your AO 2.1 protocol. And the second one, what is spatial stream? This one. I think you have already learned in the lecture, right? But basically, is normally we have 4 spatial streams, so which allows us to use the same area of frequency space to transmit and receive multiple streams of the data. But in the cutting edge protocol AO 2.11ac, we have allowed to use up to 8 spatial stream. And the modulation, there's some different modulation here. Have a look at the table. The CRAM, we have already learned the CRAM, right? And the BPSK, something like that. So basic idea is if the more complex the modulation, the higher the data rate is. So, but the more complex modulation like this one, it will require very good environment, very like should be have less interference and maybe have a good line of sight environment. Does this make sense? So it will have very high transmission like efficiency. So when we're talking about the transmission efficiency, so it comes to the coding. I'm pretty sure we have learned a lot about that because we need to calculate the speed related to the coding stuff. For example, this one is about 83.3 efficient rate, sorry. So basically the coding rate is the indication of how much of the data stream is like being used to transmit the useful data. And the OFDM, orthogonal frequency division multiplexing, is a very important concept. So if you don't know what is OFDM or not really sure, please have a review of the lecture, or you can have a look of this video here. It's a YouTube video, but we are not going to have a look of it. It's just very simple explanation. And the last one is the GI, the Grodd interval. So what is that? Basically, it's the interval between each signal. Like you can see, they have some interval between them. So this is the interval of them. So basically, we use 400 nanoseconds or 0.4 microseconds as our interval. And we also can use 800 nanoseconds as our Grodd interval. Let's back to this table. So when we have learned all the concepts here, so we should be able to read this table now. The index, already told, and spatial streams, and the modulation, and the coding. So how can we like calculate the speed if we got all this information? For example, I will open a file here. Let's find the packet. Okay. So the data rate is here, but if we lose this, lose this information, can we calculate the data rate without with other information? The answer is yes. So we can use this table. Have a look of it. Just select the file type is HT, right? And the 7, you can see. And the MCS index is 15. So we find the HT in the table and 15 here. And the MCS index is 15. And the bandwidth is 20 megahertz. 20 megahertz is here because we are using the AO2.11n protocol. So which is this column instead of the following columns. Does that make sense? So we use this column and find the 20 megahertz. And the short GI, which means we use the 400 nanoseconds GI Grodd interval. So we select this column. And because we are at this row, so the speed should be 144.4 megahertz per second. Megabits per second, sorry. So that's how we use this table to calculate the speed. So does that make sense? And this table will also help you to write the report. Okay, that's all the prerequisites, I think. My adapter does not show GI. Should I buy a new one? No, I don't suggest you to buy a new one because if I a new one does not support to get the GI as well. So I will give you a solution later. Is that okay? Let's just have a look of the task at first. Have a look of this one. I'm not going to read through all this stuff. It's pretty long. Can have a look up here. So for the task 1, basically we have 3 tasks in this lab file. So this one is the first one. In this one, all we need to do is at first do the data collection just like the previous lab. But this time, what we need to do is move the phone away from the laptop and then bring it back slowly. So it may take maybe 1 or 2 minutes, and you can filter it and save it as a CSV file. So this one should be pretty easy because I think you have already done in maybe lab 2. So if you have the lab 2 dataset, maybe you can just directly use it. But you need to make sure that all the staff is following the documentation, okay? And the second task, the second part of the task 1 is analyze the RSS and NCS. The RSS is the signal strings, right? We have already know how to analyze the signal strings. But what is MCS? So let me open this one. You can find the MCS indexes here. So I suggest you to observe the MCS index. I apply a column in my table here. You can see the MCS is 15 for this package. But if I scroll down a little bit, you can find it's become 14 now and 12 even. And continue scroll down. Here you can see it's fluctuate. The index is changing. So you need to observe the difference of the MCS index. And you can also have a look of the data rate. Because basically, if we have like higher index, we will have higher data rate. You need to observe by yourself. So in the task 1, we want to observe how the distance affects the data rate, as well as the MCS. So you may need to plot some graph like the previous lab, and then write down a commentary. And this is for the task 1. It's pretty simple, isn't it? Let's have a look of the second one. Is you can see the text almost the same. So the task is almost the same, I would say. But in the data collection step, it's a little bit different. We are required to bring an obstacles. So what does this mean? So when you start capturing, there should have nothing between your sender and receiver. And then you just push your obstacles such as a sofa between them and then remove it again very slowly. And then we can use this data set to analyze it. So in the task 2, we just want to analyze how the obstacles affect the MCS and data rate. Of course, the RSS. Do you have any question like for that? Basically, it's just suggest this one, assume this one is your sender, and this one is your receiver, right? And you just, maybe this one is your sofa. You just push into the middle and remove it again. Maybe remove it again. So this will also take like 1 or 2 minutes to finish it. Just make sure it's very slow. And the task 3, the data collection. Sorry, we got a question here. Do we need to draw a graph like what you show, which columns are HT, special string coding? No, you are not required to like draw a graph of this one. But if you can, to make it very simple to understand, you can do it. Yeah, we don't mind you have provide this table, but just do not just copy this table like this. But you can show how your MCS or the data rate changing, or even the modulation or coding changing, if you find it useful. Okay, let's have a look at task 3. Also very similar one, but for the data collection, you may suffer a lot from this one because it's much complex. Oh, sorry, I put the wrong one. Maybe we should have a look in here. So what should we do in here? Let me find it. Here. Okay, the key steps are here. What we need to do is turn on a smart TV and watch a video as well from the internet. But you need to pay attention here. The TV should also connect to your hotspot, so they should keep in the same internet. And after that, you need to turn on a microwave oven and you use the 2.4 gigahertz. Because we know the microwave oven is operating in the 2.4 gigahertz to heat the food. So it may interference, very fierce interference when you open the microwave oven. So in this task, we just want to observe how the microwave oven and another TV to interference our Wi-Fi signal. Right, I made a mistake here. And for the second part of task 3 is just analyze how the microwave operation affects the MCS data rate. So I have a small suggestion here is maybe you should like take a note of the time, like maybe at the 0 second, I turn on the data collection, and maybe at the second, I turn on my TV and connect to the internet and play a video, and maybe at the like 20 seconds, I turn on my microwave operation, and at the 40 seconds, I turn it off, and something like that. So you can make a note of the time that you do each operation, and it will help you to analyze the graph. Yeah, and that's all for all the tasks. So finally, you need to submit at least 3 CSV files into a zip file, and as well to submit a report. So for the report, you should split them as 3 different tasks. Just analyze, maybe draw some graphs in task 1 and write down a commentary, and then also draw another graphs for task 2 and write down a commentary, and the same for task 3. And that's all. Let's have a look here of the general questions. Some students may have their trouble as they cannot observe the data rate change. If you open this kind of stuff, maybe in the previous lab, if you open the file in the previous lab, you may find the data rate didn't change. So that is pretty normal because we operating the data collection in indoors area, so which means the signal strength may pretty high. So our data rate may remain a very good standard. So if you go to the outdoor, you will find the data speed change a lot. The data rate is different. And some students may have some trouble on capturing the correct packets which have the MCS index. You may find there is nothing information about this, like related to the MCS index as well as the data rate. You cannot find the information inside your packets. So the reason is very complicated. It may be because your network interface does not support this kind of stuff, or maybe your configuration is wrong. You didn't open the monitor mode or something, and maybe you didn't select the correct packet. There is only have, I think, not every packet have this kind of information. So you maybe need to have a double check. So if you take lots of time and still cannot capturing the packet, we provide you with a sample capture file here in the link here. So there are 3 files for each task. So in case you cannot capture any packets by yourself and you have tried a lot of different methods, so just simply use this one in your report and analyze it. And I also provide a comment for each task. It describes how I collect these 3 different files. Okay, and you can find these files in the GitHub link here. In the lab file section, we will have a link here. And I can also send you the link right now. Yeah. So you can download it in case you cannot capture any file. So if you use my sample data set, you are required to like filter into the CSV file, apply a filter, but actually there's nothing to apply. Just save it as a CSV file, and you should note in your report that you are using my sample data set. Okay. How to make the data rate appears as a column. Okay. Something like this, right? You can write, maybe you should find the packet in any row, and you can find the data rate here, right? And right click it, apply as column here. Just click this option here, and you can find the data rate is in your table. It's okay to only use microwave for task 3 because you don't have a TV. Ah, yeah, of course. So if you don't have a TV, maybe you can use another like iPad or another device such as cell phone or other electronic device which can connect to your hotspot and play a video. That will work. So if you still have nothing like can connect to your hotspot as well and play the videos, then you can just describe you don't have anything. So we won't blame you. Just describe it in your report. And this, what we're supposed to do is to observe the change in signal strength and the data rate, right? Yeah, basically, yes. So, but you need to have a look of the documentation. So just strictly follow the question here. It asks you to analyze and explain, right? So just follow this. But the main idea is to observe the data rate. A quick question about grade for lab 3. The grade shows for in my submission, it shows 3.85 in grade. Oh, that's weird. Maybe you can send an email of the screenshot to us so we can have a look. I don't think we can put this 3.85. Maybe it's just a bug, I guess. But you may need to send an email. Yeah, so if you find your like a submission, if you find any trouble at your marks or for the previous lab, you just send us an email or post it on the forum as soon as possible. Yes, can I ask a question regarding to the term projects? Yes, we can. Just feel free to ask any question related to that. And if you like, maybe you can send me some suggestion about what should I do to help you to like organize your term projects. So maybe I can prepare for that for our next tutorial. So if you have any question regarding to the term project or in future labs, just send me and I will prepare for that. I have a question in regards of the lab 3 estimate with 1 day delay, the penalty is 10%, right? But I got 304. So I think they may always have other reason to give you this mark. So do you have any feedback on your report? So they will provide you the feedback. Maybe you didn't finish some part of in your report. Maybe you missed something. But if you insist you have nothing wrong, so maybe you should get a higher mark, then you can argue, send us an email, and we will have a look and explain to you.
Hi, Ray. Can I ask you a question regarding the term project?
Yes.
Right now, because I was just reading the Lab 9 instructions, and it suggests us to have produce the 50 to 100 packets per second continuously. But
Yeah.
however, when I was conducting the experiment,
Yeah.
there was always a gap, like 0.6 seconds, or sometimes it's even larger, like 1 or 2 seconds before the RSS packets. So I found these, the gaps very like annoying because I can't get rid of them. And I have like dozens of like 1,000 of packets transmitted within a 0.1 seconds, but it is very hard to do the pre-processing if we have such gap, because we can't use the windowing techniques suggested in the paper, the master thesis. So what should we do to produce a continuous stream of packets, or we can receive a continuous incoming RSS data?
Oh, this question.
Thank you.
Yeah, we didn't realize that this question, so we may need to have a look. Maybe you can, okay, send me some sample of your data so I can maybe discuss with other tutor and the lecturer. So we didn't realize this question.
Yes, yes, sure. So do you want me to present it to you at the moment or send it to you afterwards in an email?
Yeah, if you like, maybe you can show me right now and send me the file.
Yeah,
So
sure.
can you,
Give me a
can
few
you,
seconds, please.
yes,
Thank you.
okay. I will stop the recording right now.